So last week, I worked through creating a tRPC example app with tRPC core member Ahmed Elsakan, who's just great. If nothing else, you should make sure that you go and follow him on Twitter now. Anyways, I just wanted to recap what I learned from this experience, and most of that has to do with tRPC. But the experience also triggered a few thoughts about NX's role in projects like this that I'll go ahead and share at the end. So for tRPC, here's what I expected. Yeah, that's really all I expected initially. And to be honest, I wasn't all that jazzed about it. Coming from the NX world, full stack type safety isn't all that new. Full stack type safety and IntelliSense is a big reason why a lot of people end up reaching for monorepo tools like NX, so that you can easily share types and other resources between your front end and your back end easily because they're living in the same workspace. This is actually one of the big reasons why I initially gravitated towards NX and eventually got hired by them. But back then I was writing my front ends in Angular and my back ends in Express. Both of them supported TypeScript at the time, but the tooling here was kind of sparse. Maintaining these types and interfaces was a very manual process. And that process ended up looking something like this. So we'd have something that looked like a shared models or interface package here, which really just looked like interfaces or types for response bodies or for request bodies maybe. So then moving to an example Express implementation, we can see here, this is a route on my API to get our versions. I've got some middleware here, but then I go into the actual request handler. We could see on the right-hand side of my screen here. I'd need to make sure that my request handlers were properly typed with an interface that came from one of these shared libraries, as we can see here. And I need to make sure that any kind of network requests I made on the front-end side of my code would also import from the shared library and use the same interface when I perform my fetch. And if something about one of these interfaces had to change, then I could change it here, like so, and then I could just go out and see what broke on the front end or on the back end. So this is already very manual and a little problematic. Problematic because I would do this when I was disciplined about writing my interfaces and my types and putting them in a shared package like a good boy. But oftentimes I would actually just create these interfaces maybe just in the front end or just in the back end, whichever I would happen to be working on at the time, skipping the step of putting it in the shared library, and then without even realizing it sometimes, I would have these types that were diverged between the front end and the back end, and figuring those things out was actually painful to do. But what's worse is that on top of having this step of having to be disciplined, is that assuming I was being disciplined about my interfaces for response or request bodies and things like that, that actually doesn't make sure that the routes, as we can see here on the Express server, are actually maintained. So when we have to make some sort of client or a fetch wrapper for this API, which I have one here, and see our interface for our world server client. And here is our method on that client to get our versions. Now, if we go down to the implementation of this interface down here where we create our world server and go to the actual get versions function, we can see that there's a bit of magic strings happening here between my Express app's route and the URL for my fetch request here on the client side. So if I were to change, for example, the route here, I get no immediate signal that these things are mismatched. In fact, if I wanted to have some sort of automated way of making sure I didn't break stuff, I'd pretty much have to write an end-to-end test here, maybe standing up a version of this client and sending a fetch request to a running version of the API, and making sure all of the methods on this client completed successfully, which normally I just didn't do. So coming back to our diagram here, while this doesn't look too bad, we'd actually need to adjust this a little bit because our front-end app is actually going to need this API client, which is going to need to know about these shared types. And then if we wanted some level of automation to make sure our client and our back end were kept in sync, then we'd need to write some sort of API integration test that would stand up both a version of our client or create an instance of our client, as well as stand up our backend and make sure that all those methods just worked as we expected. So in retrospect, ultimately, my legacy version of full stack type safety actually wasn't a pain remover. It was a pain front loader. Rather than hitting an annoying problem at runtime when I got a response from a network request that didn't actually match the shape of what I expected, I was front-loading that pain inside of this whole process to make sure that I hit that pain initially at the start, and that way I would make sure that while I still had the pain of doing all of this, at least I wouldn't hit that pain during runtime, because I would make sure that I was hitting it during dev time, as long as I was making sure that I had all these things in place and that I was being disciplined. Now, I don't want to downplay the benefits of front-loading that pain. I think that's actually a worthwhile trade to make. Everything in engineering is about trade-offs. And really, this was a huge improvement over my life before I really adopted a monorepo approach, where I'd maybe mistype the response body inside of my front-end application, and then I'd hit an error during runtime, and I'd have to trace that error down, and sometimes that would take minutes. And I need to cross-reference code between my front-end project and my back-end project, which are both in different repos, before I end up hating myself for just doing something silly like misspelling a field name. But as impactful as this change was for me, from going from nothing to now full stack type safety back in around 2017, I actually think that the jump from this version of manual full stack type safety to tRPC's approach is even more impactful than this. And here's why. All that pain that I was front-loading inside of this manual full-stack type safety approach is now just gone with tRPC, and that's a huge feat. Again, here's the diagram of maintaining this full-stack type safety in my manual world. You can see there's 5 nodes here. And what you can't see is the discipline required to make sure that these versions of the shared types are being used across all of them. And now here it is with tRPC. And again, what you can't see is I don't have to be as disciplined here in manually maintaining anything, because when I create my client, my tRPC client on the front end, the typing on that client is entirely driven by our actual code for our backend application. And that's pretty huge. And to see just how huge that really is, I put together this timeline based on the recording of the live broadcast of me and Ahmed. Now, I released a pared down version of this that removed a lot of talking to people in chat and irrelevant conversations, and just got to the core line of what we're trying to implement with our code. And that came out to roughly a total of 42 minutes. And when you break that down, it looked like about 2 minutes of initial scaffolding to create our workspace, and then 12 minutes of creating our backend application. And then we needed about 5 minutes of front-end setup to take some actual manual steps to set up Tanstack query. We'll talk about that in a second. And then we saw about 24 minutes total to create our front end. Now, in all of this time, I think we spent maybe 30 seconds actively thinking about types. And that was when we dropped in Zod for the tRPC input schema. With my prior full-stack type safety approach, I don't think it would be an exaggeration to say that we probably would need to double the time spent on scaffolding here to support the more extensive structure. And then we'd probably need another 15 minutes or so to create our types and create a client, and probably another 5 minutes on both the back end and the front end, just sprinkled throughout the implementations to make sure that we were being disciplined, that we were keeping all of our interfaces in line, and just generally being good about sticking to the types from this other library. So with my obviously fuzzy math here, it looks like using tRPC took what would have been a 70-minute endeavor and turned it into 42 minutes. So that's like 35% savings, I think, which I think is pretty great. Beyond just the time savings, though, I think there's actually a huge benefit to the reduction of cognitive load for keeping track of all of these types. Just take a look at this moment, for example. Toggle and give it the ID. Mm-hmm. That is so neat that went all the way down, because I wasn't thinking this. I was thinking it would be like this. And the tooling there just made it so I didn't even have to think about that. That was really cool. Yeah. So as you can see, I was completely leaning on my tools to remember these things, where most of the time, even if I had these interfaces in place, I'd still be probably trying to remember exactly how those things worked, and again, be disciplined in terms of making sure I was using the correct interface. And using tRPC removes all of that cognitive load, so I didn't even find myself thinking about types during the entire work session that we had, which was really great. I just benefited from them. It was painful, didn't think about it, just benefit. Awesome. So that was the first of two big things that tRPC really surprised me on. Because like I said, I wasn't that jazzed about this when I first got into it, but I am now. But like I said, there was a second major benefit to tRPC that I just didn't see coming. And that was the integration with Tanstack query. Now, I had worked on some NX automation to make the scaffolding step really, really easy. Because one, that's never fun to do on live stream, obviously. And two, that's one of the main things I always want to highlight about NX is we just don't have to think about this step. Hardly at all. It took us 2 minutes. And that is doing a lot of lifting. That's setting up TypeScript, Git, ESLint, Vite, Tailwind, testing, all this other stuff, unit tests, end-to-end tests, all that stuff is available and working for us out of the box thanks to the tool set that NX gives us. But we'll talk about that later. There was 5 minutes here of front-end setup, and a lot of that was just because when I was looking at tRPC, I hadn't actually realized the potential integration here between tRPC and Tanstack query on the front end. And so there's a couple interesting pieces here. One of these is that I really think the 5 minutes of front end setup that we saw here, I think that could probably go away if I had known about this integration before time. And thankfully, Ahmed and I are working together on a narwhal/tRPC package that will hopefully take care of all of this stuff for us. So y'all can get all of this benefit going forward for all of your projects if you ever want to use NX with tRPC and Tanstack in the future. But putting all of that aside, we were actually able to do some really cool stuff with Tanstack query that I just hadn't anticipated us being able to do inside of the live stream session that we had. And I'm a bit ashamed to say I just hadn't picked up React query or Tanstack query before. Part of this is just because I've had sour experiences with Apollo, and when I saw what React query was doing, it looked a lot like that. And a lot of what I had experienced with GraphQL's Apollo client, while a great project, it just made me feel oftentimes like I was completely not in control of my cache during runtime, and I had no insight to really what was going on and what was triggering events to cause the cache to get invalidated or cause refetches or anything like that. I was pleasantly surprised to find that inside of our live coding session, I didn't hit any of that friction while working with Ahmed using Tanstack. In fact, I was consistently pretty pleasantly surprised with the features that Tanstack supported, like for instance this moment.
Also, the reason for multiple get all to dos now, because by default, when React query detects unfocus and focus on the browser, it will refetch. But
Really
yeah.
neat. How do we stop that? That's neat, but I don't want that right now. And so my first impressions with working with Tanstack were overwhelmingly positive. There was a bit of this going on where I just didn't really understand what all was happening or how I should use things. I know there's obviously a way that these should be used and these could be used better, but I think any of that friction was completely on me and just because of the fact that I'm not familiar with it yet. And Ahmed made some pretty bold claims about how good Tanstack and tRPC actually is.
I think once you get used to it, I don't think you will ever come back.
And to be honest, I think I may be agreeing with him, which is a shame. I love Redux and Redux dev tools in particular. But the return that we got on the time and the work we did, I think was actually really good. And on the front end side, at least, I think that's mainly thanks to the Tanstack query cache and everything that it was doing to empower these things. So for example, one of the things we did was our to-do API. We specifically designed so that when we added a new to-do to our API or deleted a to-do or edited a to-do item, we made sure that the responses to those mutations would contain enough information to adjust our cache so that we wouldn't have to invalidate our to-do cache or just make another network request after the mutation had already gone through to then go back and refetch our new version of all of our to-do list. And we did that all on the live stream. And with Tanstack queries cache, it really wasn't that bad. So that part in particular I thought was really cool. So to recap the main points of my session with Ahmed, number one, painless, effortless type safety, full stack type safety with tRPC, huge benefit, huge time saver too. Number two, Tanstack query, quite nice, we'll use again. And a final point that's been kind of hanging around in the background so far, but we addressed it a little bit. I think I realized something in particular on this live stream about the real value of NX in light of all of the work we had done inside of this project. And that is that NX's job is to be in the background and give you benefit without you even realizing. For example, there was no friction in having our backend tRPC server and our front-end client in the same workspace. That just worked. We didn't have to export a package and import that package into another workspace in order to make it work. It was just there. We just imported it like we would with any other TypeScript import. We had a nice command that was just going out and running our backend and our front end development environments in one command with really nice terminal output, if I do say so myself. And like we said before, it took us 2 minutes to set up the entire app, to go from actually nothing to, okay, we're one command away from starting a full stack where the two pieces are actually communicating with themselves already. And because of the tools that NX gives us, Ahmed and I are going to look into reducing some of that load even further to help incorporate Tanstack in the future. And we haven't even got to some of the huge benefits of this, which is if this project were to scale, we would now have the ability to cache our task results. So if we ever ran a build on our application or even just one of our projects and the code hasn't changed, we would have just replayed the prior build of that package. Same with a lint command or a test command. If the code hadn't changed, you never run the same task twice. Which if you pull up the repo, that's actually working right now. We didn't even notice it when we were live coding. And if we wanted to set up CI/CD, we were one generator away from running the Narwhal Workspace CI generator that would have just set us up for GitHub Actions. And because we were already using the NX Cloud Task Runner, we were like a couple steps away from just setting up first-class CI/CD pipelines. But I think if you had just come in at maybe any point besides these 2 minutes we were working on the scaffolding, you probably wouldn't have noticed we were even inside of an NX workspace. And that's kind of the point. Everything just worked. We got a bunch of benefit and we didn't really have to do anything for it. So I think that's NX's role. And if you're watching this video, you probably already realized that in some way. So if that does describe you, I encourage you to like this video, hit the subscribe. Let me know in the comments if you like this kind of video and what kind of live coding events you'd like to have us do in the future. I'd love to get your ideas so that we can make the NX Live series a really great experience for everyone. So thanks so much for watching, y'all. Check out the links in the description below if you want to get plugged in more to the NX community or find out more about NX. We've got a whole series of links there. And be on the lookout for more live streams, more videos, and more awesome stuff from NX in the weeks ahead. Cheers. See y'all next time.